Hi guys, so welcome to this episode of the coding thing, whatever it is, final year project diaries, right? And yeah, in the previous video, we were not able to finish the implementation of keeping track of the notes because the time was up. So yeah, this video I'm going to set my 25 minutes and we are going to start work. So we were saying that we wanted to keep track of the new terminals that are already in a node. That's already in a node, or should I say, that's already in nodes like this, so that it's possible for it to be single, right? And now I'm going to do that to your terminal intersections, and I'm going to set that to an empty set first, right? I'm going to set it to an empty set first, right? And what I'm going to do is to also keep track of the nodes the new terminals intersect with. And I was saying that keeping track of these two things would actually help me, like the number of items in these two data structures would actually help me understand which of the cases we are dealing with, the number of items in these two things, right? So I could be like nodes intersected with, and that should also be, should I say, an empty set, right? And now, so if I consider these intersections, right, intersections, this is supposed to be, if the length of this intersection, right, what should I say? Can I actually find a length of this? Yeah, I can. Yeah, I can. If the length of this intersection is equal to 0, it means that new terminals don't intersect with the node. So we continue to the others. So what do? We continue to the others. And if the length of intersections is equal to 1, means that what? Only one of the new terminals intersects with current node. So update, what do? We update the sets outside the loop that keep track of the terminals and nodes intersected with. So what do? We do what? Terminal intersections dot append, not dot append, dot add item, I get, or we can do that dot union dot update. Wow. I'm not going to do that. I don't know, it just feels weird, right? Or it's because they don't know what it is. It's a set. Right, and this is also a set. So we also do terminal intersections dot add. Nice, getting better. We dot add what? The item in there. The item that's inside the intersection. So what I'm going to do is just do next iteration or iter of the intersections. That should give me the item in there, like for what we learned in the previous video, right? And if the length of intersections is equal to 2, which is the last case, it means that what both new terminals belong to this same node. So yeah, both of the new terminals belong to this same node. So basically what we are going to do is to, oh, I forgot one thing too. As we are adding this here, as we are adding the terminals and we are updating this, we should also update the other one, the nodes intersected with, right? So nodes intersected with, right, dot add, then we are basically going to add the node that is intersected with. I'm just going to use the node ID here, right? Node ID. Let me make it node I. Or let me just leave it how it is. Notice that when we add ID instead of the actual node. I mean, why should we be adding the actual node? It would just be a lot of work, right? Right. I'm actually yawning right now because I'm actually very tired and I don't think I'm thinking very clearly. But we have to get this working, right? So if it means that both the new terminals, if the length of this is 2, it means that both of the new terminals belong to this same node. What that means is that the terminal intersections, we are going to add both. So what we are going to do is that we're going to for intersection in the iteration or like iterable of the intersections. So essentially, like for each of them in there, we are going to add that to the terminal intersections that we have above. So intersection, simple, right? And so what this is doing is what, add both new terminals to the terminal intersections above. And after doing that, we also make sure that we update the nodes intersected with, right? So nodes intersected with dot add, and I'm going to add a node ID, right? So I mean, if everything goes well, then it means that after we have run this for loop, we have the length of this will give us the cases, right? So first of all, let's assume that it intersects with none of them, right? This particular one, none of the new terminals is already part of a node, and that means that both of these would be 0, right? Because it means that this would always be 0, right? So if if length of nodes intersected with is equal to 0 and length of terminal intersections is also equal to 0, then we can say that what, the new connection doesn't belong to any old any old node. So what do? We create a new node for it. And how do we do that? We create a new node by doing what? Self.create new circuits node, and we are going to pass in what? A node count, right? Node count should be equal to what? The length of the nodes, right? Self.circuit nodes, and the other one, which is what? Components terminals, and that should be equal to self.selected terminals. Fair. That's case 1. Case 2, why is that elif there? Oh, I didn't write anything, that's why it went there, I guess. Elif, the length of what? The nodes intersected with is equal to 1. So if the nodes intersected with is equal to 1, and the length of the terminal intersection is equal to, you see, if you intersect with one node, then at least your terminal intersection should at least be 1, right? That makes perfect sense, right? So if you intersect with one node and it's only one terminal that intersects with that node, then it means that what? Connection is already part of a single node. So what do? We add the new terminal. No, we add a new terminal that's not already part of that node to the node. And how do we do that? We get the node, right? How do we get the node? So first, get the node, and we do that by doing what? Node should be equal to what? Self.circuit nodes.get. Oh, you know what? I already have the node ID, right? Node ID should be equal to what? Next, it's whatever it is of what the nodes intersected with. That should give us the node ID. So get a node ID, and then we can use the node ID. But then after getting the node ID, you also have to get the new terminal that's not already part of the. How about I just convert? How about I just append it first? Hold up. Let me write some trash code. Let me just write some trash code. Allow me to do this. Allow me to write trash code. Right. How am I going to do it? Oops. I've created something somewhere, right? Anyway, how am I going to do it? First, I'm going to get the terminals involved in the node. Right, how do you do that? So terminals, is it connected terminals or something like that? How do I call it here? Yeah, connected terminals. So connected terminals should be equal to what? Self.circuit nodes.get. Then I guess this particular circuit node, and I do what? Component terminals. They should give me what? The connected terminals. Oh, it's actually component terminals. And one way to do is that what? For new component terminal in self.selected terminals, component terminals.append. Component terminals.append what? Should I make a copy of this just in case? I don't want it to be changing that one. Does it even matter? Component terminals.append new component terminal But you see, after doing this, there could be repetition since I'm very sure that there is already one inside there. So all I need to do is to make sure that I convert it into a set and I convert it to a list again, right? So I'll basically just like component terminals, or component terminals would be equal to a set of what? List of sets of what? Component terminals. And that's supposed to like remove the remove the duplicates in there. Remove duplicate. And then I'll set it back to it. Now set the component terminal of the node to the new component terminals. And what would I do? I'll basically just self.circuit nodes .get node ID dot component terminals is equal to component terminals. I mean, this is something, right? This is something that I could do, but I think we could improve it later. For now, let me just continue with the next case. Now, the next case would be if the nodes intersected with is still 1 and the terminals intersected with is 2. What this would mean is that if two of the new terminals make intersections, but then it's just with the same node, then it means that this parallel connection thing came in, right? So it basically means that what? Parallel connection between the two components involved. Let me actually print that. Parallel connection, right? And if the length of not the length of the circuit node, the length of nodes intersected with is equal to 2, and the length of the terminals intersected with should also be equal to 2. Obviously, if this is equal to 2, this should also be equal to 2, because there's no way one thing would be intersecting with there's no way one terminal would be intersecting with two different nodes. That wouldn't make sense, right? Like, that would defeat the purpose of our logic, because one node should have that terminal. That terminal can't be part of another node again. So we don't want that. So here, then it means that there is a short circuit, right? Short circuit between the two nodes. And that one too, we haven't handled it yet. Short circuit. Short circuit between nodes, right? And this should like actually end our logic. It should work. If it doesn't work, then I guess it's a waste of time again then, right? So let's try it out and see. I don't know why I'm clearing the empty terminal. Wow. Python app.py, and that should run our app. We're already printing out the stuff in, right? Let me see. Yeah, we're already printing out the stuff, so it will show. Let's just make things work and see what's up. So resistor, sources, source. Why is it seeing that as a component terminal click? Wow. Maybe I wrote some print statement somewhere that doesn't make sense. Only God knows what's happening. Anyway, so make a connection from here to here. Node 0, right. Now if I make a connection from this same place to this same place, and something happened. Dictionary object has no attributes add, but I'm using it as a set, bro. Actually, you can't define an empty set like this, so I'll do set like this. Yeah, this should work. I should have thought of that. I thought I knew Python better, but I couldn't think of that. Wow. Should be ashamed of yourself, Paul. Anyway, so we have this connected to this. There's no node already, so new node was created. Now I'm trying to connect this to this. Right, that works. So now we have what? The voltage source and the two resistors being part of the same node. Wow. Now if I try to connect this with this, I didn't click the first one apparently. Then now we have two nodes, right? And then if I try to connect this with this, two nodes, and this is getting nicer. But if I try to connect this and this, then there is a short circuit, right? So you should tell me that there's a short circuit. Yeah, it says that short circuit between nodes. Lovely. That works. And the parallel thing is when, let's say, I have another component. I have another component here, and I'm trying to connect from here to here, and I also connect from here to here. For now it's not a parallel connection, but now if I try to connect from here to here, then that should give me a parallel connection. So that gives me a parallel connection. Lovely. And as you can see, this node 0 is now having how many components there? How many? 1, 2, 3, 4, 5, and that works 1, 2, 3, 4, 5. All of them accordingly. Like you see, the resistors, terminal 0 of resistor 1, terminal 1 of resistor 3. Yeah, like this is awesome actually. So now I guess the logic is working, but I think we have some things to figure out. Like, let's be honest, this thing I've written here, where is it? This thing I've written here is just the definition of crappy code. Let's be honest. It's left with 1 minute, but because it's left with 1 minute, I'm going to leave the crappy code in here. I might like change it later or something. Hopefully I come back to it. But for now, I'm really glad we were able to fix this, because when I realized the error, I was like, what the hell was I writing the last time? I was shocked. Like, coming to think of it, I was shocked. Wow. Right, so guys, that's it for this video, right? But in the next video, what we are going to try and do is to now that we are able to keep track of this, we would make a button available for the user to click for him to actually simulate whatever he or she has built, and that button, when clicked, would basically call some functions that would be created in here inside the simulation backend and pass in the components terminals and the components that are part of it. So like, when you have the terminals of, sorry, my alarm is going off. When you have the terminals of a particular circuit, you can use PySpice to simulate that circuit. Hopefully this final year project is going on well. It seems like, I don't know, I feel like I'm rushing it, or I'm not rushing it. I feel like there are things that I've not considered, like how am I going to actually simulate this parallel circuit thing? And how am I going to simulate this short circuit thing? you got you get what I'm saying. So guys, that's it for this video. I thank you guys for watching. If you did enjoy the video, you know what to do. Leave a like behind, subscribe to the channel if you're new around here, and I'll see you guys in the next one. Cheers.
He got the venom, a tangible weapon, no coming in second. This life is a lesson. He got a new engine from pain, it's a blessing. New focus, no guessing, just bold and obsession. All in his possession, you got their attention. Now leave an impression and take your redemption. Just kill, no discretion. Your mind is a weapon. 11-11, it's time for progression.